Now I've looked at 2a here, which is the square root of xy. So it's a product, and we can break the square root up into two questions. And there is another way we can do this question, which I'll show in a second. So u is x to the half of what x, and v is y to the half. So when we differentiate these, bring the power to the front, decrease the power by 1. But the one with y, we need to also remember to put dy by dx. And then we can go ahead and use the product rule. So u dv plus v du. And I can see common factors here. I got half as a factor, x to the half and x to the negative half. So we take x to the negative half because that's the smaller power. And then y to the negative half and y to the half. So y to the negative half because that's the smaller power. Oops. And then if we times x to the negative half by x, that gives us x to the 1/2 because we add the powers together. Negative 1/2 plus 1 is positive 1/2. And for the other one, also dy by dx as well. And then the same for this one. We've got a half, x to the negative half, which we also have here. But y to the negative 1/2 times by y gives us y to the positive half, same reason. Negative 1/2 plus 1 gives us y to the half. And that's about as much as I can do. Now I could do the same thing by doing the chain rule for this question. So if I rewrite this as xy all to the power of a half, I can bring the power to the front, decrease the power by 1, and then I need to times by the differential of what's inside the parentheses. Now to do that, I need to do the product rule. So I have x here times by the derivative of y, which is 1 dy by dx, plus the second one, which is y, times the derivative of the first, so the derivative of x is 1. And what you can actually see is you do end up with the same answer. So a couple of different ways that you can think about doing these questions. They will both still give you the same answer.